Hi everybody. So today I want to walk you through the 13-5 cosine function. Now this one's actually fairly similar to the sine function. So I'm going to go a little bit quicker through the introductory parts right here. So once again, we have our unit circle. Okay, we're starting at 0, we're rotating around to 2 pi. And remember that it's always cosine theta, sine theta for the values. Last time we did sine. Now we're going to be doing cosine. So rather than looking at all the x values, looking at all the, before the sine, we're looking at the y values. Now we're going to be looking at the x values of this unit circle. And we're just going to be plotting those. Okay, so when we're looking at the angle here, we see that, well, when we're at 0, x is 1. So that's where we start for cosine. So there we go. There's 0. Got 0 right there. So we're starting at 1 right here, at the top, actually. And then what happens next? We rotate around. We get to pi over 2. All right, now we're at 0. Okay, so I'll plot that point right there. So that goes right there. And now what now? Now we're going to be at pi. Okay, so at pi, we are at, here we are, at -1. Okay, so I'll plot that guy. Down there. Right there. All right, -1. 3 pi over 2, back to 0 again. And back to 0, once again, we are at 1. So this curve is actually very similar to the sine curve, you'll notice. Instead of starting at 0, it starts at 1. Okay, and it keeps on continuing like a wave function, just like the sine does. So this guy's going to be going down, and then back up, and then down, and back up, and just repeating forever. Okay, and this function has the same rules for it. So if we have y is equal to a cosine b of x, everything means the same exact thing as it did before. So for example, the absolute value of a is the amplitude, it's the height of the curve. B is the number of cycles from 0 to 2 pi, and 2 pi over b is the period. Okay, let's take a look at a couple problems and see how that works. Let's start off with number 9. I'm going to do more than the problem says for number 9. Okay. So for number 9, they give you a graph and some information about the graph. Okay. So this guy, they tell you it goes from, in terms of x, it goes from -2 pi to +2 pi. In terms of y, it goes from -2 to +2. Okay, so then we want to find some values right here. Okay, so for example, min and max. Well, min and max is always talking about the y. Okay, so we see, well, what's the maximum value of this graph? Well, it always kind of peaks right here. And what number is that? Well, that's 1. Okay, so the maximum is y is equal to 1. The minimum is just the opposite. The bottom of it is always at y is equal to -1. Okay, zeros. All right, there's going to be a lot of zeros here. Okay, so you're noticing here that it keeps on repeating the same pattern over and over and over and over and over again. Okay, well, where are those zeros? Well, there's one right there. There's another one right there. Another one right there. Another one right there. There's actually tons of them. So where are those exactly, though? If I chop it up a bit more, so if I just write it out a little bit, that's pi, right? Put another tick there, another tick there. That means that has to be pi over 2. That's got to be 3 pi over 2. Okay? Well, those are where our mins and maxes are. So our zeros are in between those. So for example, at this point right here, well, what's in between 0 and pi over 2? It's going to be pi over 4. Okay, and you keep on kind of repeating that process over and over again. So our zeros are going to be at, first one is going to be at x is equal to pi over 4. Where's another one? Looks like it's in between pi over 2 and pi. 3 pi over 4. And then we got another one, kind of like right here. Well, what's in between pi and 3 pi over 2? Well, it's going to be 5 pi over 4. Basically, every pi over 2, you're going to have another 0 up and down, okay? And you can keep on going like that. I'm going to stop right there. That's going to be 5 pi over 4. 5 over 4, okay? And we're just adding pi over 2, and you can also subtract pi over 2. And it's going to keep on repeating into infinity. Okay. Now, the question doesn't ask you to do this, but let's get our equation here too. Okay. So, what's our a in this equation? Well, we see this curve. Where does it go? It goes from positive 1 down to negative 1. That's kind of the typical standard amplitude of 1. So, a is 1. Put that 1 right there. What's our period? Okay, how long does it take to complete one complete cycle? One complete curve. So remember, we start at the top, go all the way down, and we go all the way back up again. Well, that's one cycle. Starting at the top, down and up, one complete curve. How long is that? Well, we're going from 0 to pi. So our period is pi. Okay, now to get to b, I just have to solve. So remember, the period is going to be equal to 2 pi over b, all right? And we can just manipulate it. So we get pi, b pi is equal to 2 pi. So yeah, b is equal to 2. Okay, so what's our equation here? Well, our equation is y is equal to cosine of 2 theta. Okay, and this leads nicely into the next problem as well, number 11. It's asking you to sketch one cycle of the graph, okay? One cycle of the graph, period. There's one cycle, okay? All right, cool. So let's just get our pieces right here. Notice this is the same function. It's going to look a little different because we're not going to be we're only graphing one cycle, where 9 had several cycles in it. So we already know A is 1. We know B is 2. And we already solved for it before. But, I mean, if you want to do it again, the period is 2 pi over B, which is equal to pi. All right, so sketching it out. Amplitude is 1, so it's going to go from negative 1 to 1 in terms of y. Period is pi. So I'm going to put a pi right there, put a pi over 2 right there. And I'm going to sketch in the curve. Okay, and if you want, you can put tick marks kind of in between there to help guide you. Okay, so sketching that curve in, remember we start at 1. We're going to hit 0 right there. Get negative 1 right there, back to 0 right there, back up to 1 there. Look, it's going to be kind of like sine, but shifted over a little bit. And just connect the dots now. So it goes like this, like that, and up. Okay? All right, let's take a look at number 12. Similar idea. Okay, A is negative 3. That means our amplitude is going to be 3, but it's going to be flipped around. Okay. All right. What's my period? B is 1, which means I have kind of the standard period of 2 pi. Okay. So that's going to be 2 pi. That's going to be pi. Tick and tick. Now this one. So I'm going to be going through amplitude is 3, so it's going to be going from 3 to negative 3. But then remember, that's a negative 3 in the function. So I'm going to start down here instead of up there. Okay, so this guy, I'm just going to put in some dots, following the usual pattern for cosine, and sketching the curve. Okay, basically like that. Okay. Yeah. So very similar to the rules for sine. You just have to remember you're starting with a cosine. You're starting at 1 instead of 0. Okay, but it follows a similar pattern. Other than that, all right. Let's look at some algebra problems. All right. So 21 and 23. These types of problems in the book ask you to do it using your graphing calculator. For the purposes of this class, it's difficult for me to teach you how to use graphing calculators if I'm not there in person. All right, so I'm going to demonstrate. If you can read through example on page 864, that's great. If you can do it that way and figure it out, that's wonderful. Okay, but I'm going to show you the algebraic method. All right, so the algebraic method only really gets you one answer, though. In the book, they're going to give you multiple answers. Okay, but as long as you can show me the algebra of how you're solving it, that's fine. Okay, you really need the calculator to get all those other answers. It's really tricky to do it algebraically. But let me show you how to do this. Okay, so let's look at 21. We got cosine of 2t is equal to 1/2. Okay, so what we got to do is we need to solve for t here. Okay, and that means we're going to have to solve a trig equation. Okay, so remember, well, how do you get this out here? Well, you have to do what's known as an inverse trig function. And that's on your calculator. I think we've done this before. And so let's take a look at this. Or I know you've done this in geometry at least. Okay, so I'm going to take the inverse cosine of both sides. Okay, so what I'm going to do inverse cosine of the left and do an inverse cosine on the right. Now the good news is inverse cosine is on your calculator, okay? And so on the left, well, cosine and inverse cosine cancel each other out, so you're just left with 2t. On the right, you need to use your calculator, all right? Inverse cosine is just a second cosine. So I'm going to do second cosine of 1/2 and get an answer there. That's 1.05 approximately. All right. Again, that's second cosine. And now all I have to do is divide by 2. All right. So I get t is approximately equal to 0.52. Okay. One more example. So now I got negative 2 cosine pi theta of it is that's a 0.3. I'll clean that up a bit. It's a 0.3. 23. Yes, it's a 0.3. Okay. All right. So now again we have to solve for theta. Theta is the variable in this case. All right, so first of all, to do that, I have to isolate the cosine, so which means the first thing I got to do is divide both sides by a -2. Okay, so I'll do that first. So I'm going to divide this side by -2 and that side by -2. They cancel here, so you're left with cosine pi theta of, that's going to be a negative 0.15. All right, and now that you've isolated the cosine, I'm going to take the inverse cosine. So inverse cosine of the left. Okay. Inverse cosine on the right. Okay, so on the left, inverse cosine and cosine cancel. So I just have pi theta left. Again, inverse cosine of negative 0.15. Do that on your calculator. So inverse cosine. Make sure you are in radian mode while you do this. Negative 0.15. I get a 1.72. Okay, and now I just have to divide both sides by pi. And so theta is equal to 1.72 divided by pi. Okay, so 0.15. Sorry, 5, 5. Okay? And again, in the book, you're going to see several answers, okay? Because they're going to be getting it from the graph. And since the graph keeps on going up and down, up and down, up and down, you're going to get multiple answers. Algebraically, there's no clean way to get multiple answers, okay? However, if you're able to use your graphing calculator, follow the example in the book, that's great. Otherwise, doing what I did right here, giving me one answer, showing your work, all right, is great too. Either is fine, okay? All right, so I'm going to stop right here. So thank you, everybody. Please let me know if you have any questions.